Yes, exciting stuff. All right, so properties of solids is that it is a condensed state. That means its particles are far away or close together.
Close together.
Nice. They are not fluid. That means the particles cannot move. They're tightly packed. Their motion is very similar to vibrations. Most solid forms are more dense than their liquid counterparts. The exception here is
Mercury.
water. Yeah, that's hard water. Yeah. As kinetic energy increases, so does the rate and intensity of the vibrations. Eventually, those vibrations become so intense that it will break down that organized structure of a solid in a process we call dudes, melting. This is taking something exceptionally simple and putting way more words to it than it needs to. The melting point is the temperature at which a solid changes to a liquid. This is where the vibrations are strong enough to overcome the attractive forces holding it together. The strength of these forces, or the melting point, is dependent on the strength of those forces. Again, if the forces are strong, you will have a higher melting point. The melting point is also the freezing point of the liquid. This is showing you that it is same. There's that equilibrium. So, the vapor pressure of a solid. Vapor pressure of solids is less than the liquids. The example here is a snowbank. Even though your snowbank is in a temperature that is typically below freezing, you will notice, if you pay attention, that the snowbanks will get smaller even if the temperature does not get above freezing. This is because some of the molecules in the snow are actually moving fast enough to evaporate, and so they do, and that leaves a smaller pile of snow. Sublimation is the process of changing a solid directly into a gas. Carbon dioxide and iodine both do this fairly easily. Carbon dioxide, you might be more familiar with the solid name of carbon dioxide is dry ice. And then iodine, that's in the picture below. Solid iodine will sublimes, and it will form this purple vapor. Opposite of sublimation is deposition. This is changing a gas directly to a solid. Crystal solids are pretty common. We've talked quite a bit about crystal structure. That's the positive negatives attracting one another. A crystal is a substance in which the particles are arranged in an orderly repeating three-dimensional pattern, and there are 7 basic crystal systems. You can look at the chart on this slide and the second slide here that show you different setups of these crystal structures and examples of them. A unit cell is the smallest portion of the crystal lattice that shows the 3D pattern of the entire crystal. Again, you should be somewhat familiar with these because we've talked about them. The simple cubic, face-centered cubic, and the body-centered cubic. Those terms at least ringing a bell. Okay, yeah. Good. So there's some pictures showing you the difference in these. The simple cubic is your basic cube. The face-centered has the molecules in the middle of the faces, and then body-centered there will be one atom or molecule in the very middle of the crystal structure. Each of these, as you go down, are different ways to show the same exact structure. There's, I believe, 4 classes of crystalline structure. You can have ionic crystals, metallic crystals, you can have covalent network crystals, and lastly, molecular crystals. Do you want me to read through all of these, or are you capable? You're capable? Okay, there's nothing, pretty much it's all review of like all of chemistry so far. Actually, it was really just 2 chapters. I think we talked about those. The one type of solid we haven't spent much time with are called amorphous solids. These are solids that do not have the ordered internal structure. Examples of amorphous solids are rubbers, plastics, glasses, waxes. Yeah,
Rubber.
I said rubber. Okay. Glass is considered a supercooled liquid, and so it will flow. If you were to look at a glass window in an older building, the bottom will be thicker than the top because gravity is pulling the molecules down, and since it is a very slow-moving liquid, it will eventually not be flat. Huh? Don't even start.
What was in the notes for this and that?
Amorphous solids have no distinct melting point, and when they break, there's not going to be a regular pattern showing where the planes of the crystal structure are. It will be, sometimes you might even have like little swoops and swirls in the break because they're just random.